This is the second video to review for the quiz for section 6.1 and 6.2. And this video is going to focus on items for section 6.2. And again, we're going to be reviewing on page 427 in your textbook. All right, so this is number 9 we're going to take a look at first. So we have the fourth root of 32 times the fourth root of 8. So in this problem, it looks like if I just start writing this in factored form, so 32 is going to be 2 times 2 times 2 times 2 times 2. And then the fourth root of 8 is going to be 2 times 2 times 2. Now, I could just immediately bring everything together underneath the fourth root, and I have 2 times 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 2. And what we're looking for with the fourth root are factors that repeat 4 times. So I see I have 1, 2, 3, 4 2's, and I have another 1, 2, 3, 4 2's. So I'm going to take this grouping of 4 2's out and write it, and I'm going to take this grouping of 4 2's out and write it. And then there's nothing left underneath the radicals, so my answer is 4. All right, for number 10, a couple things we could do here. What I might recommend doing is rewriting this as 10 to the 1/2 power times 10 to the 1/3 power. And then this is going to be to the 8th. And then I would distribute the 8. So I would have 10 to the 4th power times 10 to the 8/3 power. Okay. Then this becomes 10 to the 4th power times. Now, a couple ways we could do this. Let's go ahead and rewrite this as the cube root of 10 to the 8th. And as I do 10 to the 8th, now watch what I do here. I'm going to write this as 10 to the 6th times 10 squared. And the reason I did that was because 6 is evenly divisible by 3 with a 2 remainder for my 8. So I can pull out the 10 to the 6th because it's evenly divisible by 3. Remember, when I pull it out, what I need to do is divide by my index. So I have 10 to the 4th times 10 squared with a cube root of 10 squared underneath. That's going to give me 10 to the 6th times the cube root of 10 squared, which if I wanted to go further, by the way, this is perfectly acceptable. If I just wanted to expand this out, 10 to the 6th is the same thing as 1 million. 1, 2, 3, 1, 2, 3, cube roots of 100. Okay. Number 11. So let's go ahead and see what we can do here. How about we distribute the exponents for number 11? So we have x to the 6th 8th power, y to the 4th 8th power, plus 2 times x to the 2/3 power times y to the 2/4 power. Let's simplify our exponents. So we have x to the 2/3 power, y to the 1/2 power, plus 2x to the 2/3 power times y to the 1/2 power. Now, if you notice, at this step, we have the same type of variable, x to the 2/3, y to the 1/2. So all I have to do is add the coefficients together. So there's 1, remember there's a 1 there if it's not written, plus 2. So I have 3, x to the 2/3 power, y to the 1/2 power. And that's all we can do at this problem. Except for I made a slight mistake in that I simplified 6/8 wrong. So let's go ahead and erase all of that. All right. So 6/8 is actually x to the 3/4 power, y to the 1/2 power, plus 2x to the 2/3 power, y to the 1/2 power. So at this step, if you notice, nothing's the same, so I can't combine it. So that is my final answer. All right, let's go back up here to number 12. All right, so a couple of things we could do here. So in the numerator, it looks like we have the same type of root, so let's go ahead and combine that. So I have 7 square roots of 7 cubed over the square root of 7 to the 5th. Okay. I can bring the 7 out, and I can write the square root of 7 cubed over 7 to the 5th, which is going to equal 7 times, this is not the 7th root, by the way, this is 7 times. And this is going to be the square root of 1 over 7 squared when I subtract my exponents. Okay, which is going to equal 7 times the square root of 1 over the square root of 7 squared. Oops. All right. Which is going to equal 7 times 1 over 7, which is going to give me 1. There's your final answer. You can do that a couple different ways. That's the way I saw it immediately. All right, so let's try maybe a similar pattern here. So in a numerator here we have 2 times the square root of x to the 4th power over 64 is square root of 64 is 8 times the square root of x to the 15th. All right, so 2 over 8 is the same thing as 1/4 times the square root of x to the 4th over x to the 15th, which is 1/4 times the square root of 1 over x to the 11th, which is equal to 1/4 the square root of 1 over the square root of x to the 11th, which equals 1/4 times 1 over the square root of x to the 10th times x, which equals, and I'll go down here, 1/4 1 over x to the 5th times the square root of x. When I pull out, I have to divide by my index. So when I pull out x to the 10th, I divide 10 by 2. That's how I get x to the 5th. Times the top and bottom by square root of x. So my final answer for this problem looks like it's going to be the square root of x in a numerator. In a denominator, it's going to give me 4x to the 6th. Square root of x times the square root of x is just x, and then I add the exponents, and that's how I get that. And there's your final answer for number 13. All right, and lastly for number 14, so let's see if I can do that to this side here. So in the first one we have y squared times the 5th root. All right, 64 is, let's see here, 2 times 2 times 2 times 2 times 2 times 2. And then we have x to the 5th times x. Okay. Minus 6, the 5th root of 2 x to the 5th times x, and then y to the 10th. Okay. In the first one, I can take out 1, 2, 3, 4, 5 2's, and I can take out the x to the 5th. When I do that, I bring the 2 out, so I have 2. I can bring out the x to the 5th. When I do that, I have to divide 5 by 5, so I have x, y squared, and it looks like underneath I have the 5th root of 2x. Okay, minus. Now in the next set, I can bring out the x to the 5th and the y to the 10th. When I bring out x to the 5th, I divide, so I have minus 6x. I can bring out y to the 10th, I divide, I have y squared. And underneath I have the 5th root of 2x. And then it looks like I have the same thing here and here, so I can just combine. So my final answer should be negative 4x y squared times the 5th root of 2x. And that's your final answer. All right, and then the last problem, number 15. Find a radical expression for the perimeter of the blue triangle shown in the square below. So the figure is obviously not drawn to scale, so this is going to be a square. So what do we know here? If this is 8, this is 2, we know this is 6. This is 4, we also know that's 8. So we see how this is going to be a square. So here's the blue triangle. We want the perimeter of this, so we need to find the lengths. Well, if this is a right triangle, we can find the length using the Pythagorean theorem. So this is going to be c. So in our first triangle, we have c squared equals 4 squared plus 8 squared. So c squared equals 16 plus 64. So c squared equals 780. Taking the square root of both sides, we have c equals the square root of 80, which is 4 times 10. Oh, excuse me, 8 times 10. That doesn't work. Okay, so how about 16 times 5? So c will equal 4 square roots of 5. So that's the length right there, 4 square roots of 5. We can do the same thing for this triangle. Call that one c. So c squared will equal 2 squared plus 4 squared. So c squared equals 4 plus 16. So c squared equals 20. Take the square root of both sides. So c equals, it's the square root of 4 times 5. So c equals 2 root 5. So that's the length here. And then we can do the same thing here. So we have c squared equals 8 squared plus 6 squared. So c squared equals 64 plus 36. So c squared equals, that's going to be 9, that's going to be 100. So c equals 10. So then the perimeter is just going to be the sum of all the sides. So I just add those up, 10 plus 4 root 5 plus 2 root 5. So the perimeter is going to be 10 plus 6 square roots of 5. And that is your final answer.